Hey everyone. Alright, so according to the newest Google form, people had the most questions over number 3, number 4, and number 6. Number 6 definitely had the highest amount of votes, and I'm going to go over basically everything that goes with that one. I don't normally do that, but I consider that a pretty complicated problem, so I want to explain all of it with you and make sure you understand it. But I'm just going to go in numerical order. I'm going to start with number 3. So number 3 says a 12-inch candle and an 18-inch candle are lit at 6 p.m. The 12-inch candle burns 0.5 inches every hour. The 18-inch candle burns 2 inches every hour. At what time will the two candles be the same height, and let H represent the number of hours? All right, so the first candle is a 12-inch candle, and it's going to burn at 0.5 inches every hour. So when I write that equation, this candle is starting at 12 inches, and then it's going to burn 0.5 inches. That means it's losing 0.5 inches per hour. So I'm subtracting the 0.5 H. The next candle is an 18-inch candle, and it's going to burn 2 inches every hour. So 2 inches are being taken away per hour. So there are my two equations. So now I just need to solve from there. Okay, so I have a variable on each side of the equation, so I want to combine like terms and zero one of those out. So between negative 0.5 and negative 2 would actually be a smaller number. So me personally, I would work with this one, but if you do it the other way, it all still works out. All right, so the inverse of subtracting 2h, I'm going to add 2h, and I'm going to come to the other side, and that would have to combine with this term here. All right, so that's going to zero pair. So on the right side, I'm left with a positive 18. And then over here, I'm just going to carry down the 12. And then negative 0.5 plus 2 is going to be a positive 1.5. All right, so I'm just going to rewrite that over here since I'm out of space. Okay. All right, so I know 12 plus 1.5 times something equals 18, so I'm going to take away the 12. That zeroes out, so I'm left with positive 1.5h, and that's going to be equal to 18 minus 12, which is 6. And if I do 6 divided by 1.5, if we calculate that, then h is going to equal 4. So that means that after 4 hours, these two candles would have burned to the exact same height. All right, number 4. On Saturday, you bowl at Mar Vista Bowl, where renting shoes cost $2, and each game bowled is $3.50. On Sunday, you bowl at Pins, where the shoe rental is $5 and each game bowled is $3.25. If you spent the same amount each day, how many games G were bowled? Okay, so let's start with Saturday. So it costs $2 just to rent the shoes, and it's also going to cost $3.50 per game. And I'm just going to write 3.5. On Sunday, the shoe rental is $5 plus the $3.25 per game. Okay, so there are my two equations. Now I'm just going to solve from there. And me personally, I would work with this term first. So the inverse of adding 3.25 would be to subtract 3.25. Okay, so I'm going to carry down that positive 2. And then 350 minus 325 is going to be a positive 0.25. And I'm going to carry down that positive 5. Okay, and then let me rewrite that over here. Okay. So now I've got a normal two-step equation. So I have this positive 2 here, so I'm going to write the inverse and write a negative 2, which is like subtracting 2. So I'm left with positive 0.25 g, and 5 minus 2 is 3. And if I do 3 divided by 0.25, that's going to be 12. So if they spent the exact same amount each day, that means that they bowled 12 games each day. Okay, number 6. There's a lot going on this problem. Okay, I usually don't go over this much, but 7 through 13 also have to do with this, so I want to make sure everybody's got a good understanding of it. Okay, so on number 6, it says Stephanie and Linda are close friends and they want to meet up to play. Although the girls live on the same street, their houses are 240 yards apart. Neither girl wants to walk the full distance, so they decide to leave home at the same time and meet somewhere in the middle. The following equations represent the distance d in yards between each girl and Stephanie's house as a function of time t in minutes. And then it shows you these two equations. So the first thing that you need to do is actually graph each one. So I'm going to start with equation 1. The distance equals 20 times the time in minutes. Okay, so if I look at the x-axis, here's our time. So that means that in 1 minute, this person would have traveled 20 yards, because obviously 20 is going to fall between 40 and 0. So after 2 minutes, they've traveled 40 yards. 3 minutes, they've traveled 60. So they're going 20 yards per minute. So it's going to follow this pattern. And you don't have to plot every single little dot, but that's just what I'm doing. Okay. All right, the second equation, d equals negative 40t plus 240. So if I look at the y-intercept is at positive 240. So if I go to the y-axis, I want to go up to 240, and I want to start here. All right, so our slope is a negative 40, and then that means rise over run, we have negative 40 over 1. So that means that in 1 minute, this person is traveling 40 yards in the opposite direction because we have a negative slope. So I want to move down 40 yards and over 1. Down 40 yards and over 1, and I'm just going to keep following that. And, oh, nope. Sorry, it's really hard to draw straight lines on here. Okay. So number 7 wants to know which girl's travel is modeled by equation number 1. Okay. So if we look at equation number 1, that's what I drew in blue. The y-axis is representing the distance from Stephanie's house. So this starts at 0, 0. So if the person is 0 yards from Stephanie's house, that would have to be Stephanie. She's 0 yards from her house, so obviously she's starting from home. So equation 1 is going to represent Stephanie. And I'm going to abbreviate that. So that means that equation 2 would have to represent Linda, because Linda is 240 feet away, yards away from Stephanie's house, so she would be starting there. So that would be the explanation there. I'm not actually going to write that out. All right, number 8, in words, explain what the negative 40 in equation 2 represents. Well, I kind of already talked about that. that means that the slope of Linda's line is negative 40. And then as I explained it, for every minute that she travels, she is traveling 40 yards. And because they're going opposite directions, that's why one is positive and the other is negative. So for number 8, it's just saying that Linda is traveling 40 yards per minute in the opposite direction. Okay, number 9, which girl is walking faster? Okay, well, if we look at the slopes, Stephanie is traveling 20 yards per minute. Linda is traveling 40 yards per minute. So obviously, Linda is traveling faster. And I just explained that. And number 10, what ordered pair would you use to describe Stephanie's original position? Okay, so Stephanie's graph is what I drew in blue. So if we look at the original position, that would be at 0, 0, because she started at her house. So if she starts at her house, she's 0 yards from her house. So Stephanie's original position would be at 0, 0. When will the girls meet? Okay, so that's when we want to see the lines actually intersect, and we see that happen right here. They have the exact same point here. So if we look at our x value and our y value, that would be at 480. Okay. And we know that according to the x-axis, those values are the minutes. So the girls would meet in 4 minutes. How far will they be from Stephanie's house? Well, if we know that they meet at the coordinate 480, 80 is going to be the yards away from Stephanie's house, so they would be 80 yards away from Stephanie's house. Okay, I am going to post the full key for this assignment, but I'm going to wait and do that tomorrow because I know some people are still working on this. So I will get that posted, and if you have any further questions, please let me know, and enjoy your Tuesday evening.